Again, welcome to today's webinar, Test Your Android App with Espresso and AWS Device Farm. Our presenters today are Nikhil Debati and Trent Peterson. Nikhil is a Cloud Solutions Engineer with the AWS mobile team. Prior to that, Nikhil worked at Qualcomm Innovation Center, where he was part of the founding team that developed the open source peer-to-peer IoT framework called Aljoin, one of the most widely used open source standards in IoT today. He has a dual master's degree from University of Southern California, Los Angeles. Trent is a project manager for AWS Device Farm, a mobile app testing platform that helps developers automatically test their apps on hundreds of real devices in minutes. He's joined AWS through the acquisition of AppTlac, an app testing company he co-founded. Prior to AppTlac, he was in the Intel Design System Automation Solutions, entrusted to test products used by millions of customers with an emphasis on simplicity and user experience. Today, Trent will also be our webinar moderator today and answering your questions throughout the presentation. Nikhil and Trent, welcome, and the floor is now yours.
Thanks, Jerry, and thanks to all of you for joining us today to learn more about AWS Device Farm and how to test your apps with Espresso. So before we get started with the details, let's talk a little bit about why you would want to use Device Farm. So as you likely know, App Store reviews can make or break applications. So what we see is that application quality is increasingly a differentiator in the market. There are millions of apps in those markets, competition is incredibly fierce, and end users are very unforgiving when it comes to problems and issues with quality. And they're very vocal about their opinions on that. And those opinions can have direct effect on your application's ability to be installed. And why is it so difficult to improve the quality of mobile applications? Well, a big part of it is the very complex ecosystem that exists around mobile. So not only do you have mini phones and tablets, we're all familiar with the piles of phones and tablets on desks or in closets that we test against, but also different environments. So things like if they're connected to Wi-Fi, if they're connected to an LTE network, if they go through a tunnel, if their connection drops, if their phone has bloatware on it, and so on. So there's just lots and lots of moving pieces, and then your application likely doesn't only exist on the phone. It uses a cloud backend. It's talking to various services. There are lots of failure points within these mobile applications. So what we saw was that when talking to developers was that this very complex system, it was difficult to test applications and ensure their quality. So you likely had piles of devices, whether or not those devices were then actually functioning or who had them when, this was a problem that we saw. And so that's why we built AWS Device Farm. And AWS Device Farm essentially allows you to focus on building great applications and great experiences for your customers without focusing on building expensive device labs, building out automation infrastructure, making sure that devices are in a stable state so they're ready for testing when you need them. We take care of all of that. We host these devices. These are real physical phones and tablets in the AWS cloud. So what to expect in today's webinar. So I'll give a brief overview of what AWS Device Farm is capable of. Then Nikhil will hop in and give an overview of Espresso and how to use it, why you would want to use it. And then the real meat of this presentation will be focused on actually demonstrating how easy it is to write tests and then take those tests that you've developed locally and run locally and then spin them up into the cloud against multiple devices on AWS Device Farm, and then walking through those reports and results and figuring out where you may have issues, before they ever get released into the wild. And then we'll have Q&A at the end. And again, you can ask questions throughout the presentation, and Nikhil or I will take care of those. So AWS Device Farm allows you to test both Android and iOS devices. You can test native applications, hybrid applications developed in things like Xamarin or Cordova, test web applications that run in Chrome or Safari, and all of this is happening on real Android and iOS devices. So these are actual physical devices, the same devices you carry around, your customers carry around. They're not rooted, they're not jailbroken. These are literally the same exact devices that you would find out in the wild. Now you have hundreds of devices you can choose from. What we mean by that is you can specify a make, a model, and an operating system. So a Samsung Galaxy S7 running a specific flavor of Android, or a Galaxy S7 that is a T-Mobile variant running a different version of Android. We support many different devices. Behind each of those devices that you can choose from, we have many physical instances in AWS data centers. So when you say, I want to run on this specific device, we go and we look for an actual physical instance that matches your specifications, and we hand those over to you for your test to run in a timely manner. With AWS, you can always expect that security is a key focus here. AWS Device Farm is no different in that regard. It was designed with from both a hardware and software standpoint with security in mind. So for instance, the devices themselves are physically isolated from one another. There's no way for one to take a video or a picture of another device or another customer's tests. The devices after every use are wiped. We remove your application. We remove various settings and other data that may have been left behind. If any of those steps fail, the device is quarantined, and we actually remove it from availability until we can determine whether or not that device can be recovered and placed back into availability. We also, where your test execution is taking place, that machine is brought up dynamically, connected to the device. We run your test, and then we tear it down. It's never, ever reused. And then from a network standpoint, the devices have their own individual Wi-Fi connection. They're not connected to a local area network. There's no way for one device to talk to another. There's also no way for somebody from the public internet to talk to a device. Everything is an outbound connection from those devices. Flexibility. So these devices are available. When we started, it was focused entirely on automation and highly parallelized tests, and that's what Nikhil will demonstrate today, is how to take your tests and run it on many devices at once and then get an aggregate report back. We also support manual interactions, so you can take a device, interact with it through your browser, touch, gesture, and so on, install your application, and reproduce issues that are manual, or if you're developing a new feature, you can use Device Farm to help verify that that's functioning correctly. And then once you have automated tests, of course, then you can spin those out and run tests against that feature. The reports that you get back contain high-level results like pass, fail. They also automatically take a video of the screen when your tests are running. We also capture screenshots, and depending on the framework, there are different ways for you to take screenshots and trigger them automatically. From your automated scripts, we will take care of pulling all of those screenshots back into your report. We also automatically capture logs. So for Android, that's going to be logcat. You can download that file, use it locally. We also are gathering things like performance data, so CPU usage, network TX and RX, thread counts, and so on, in addition to running your actual tests. So these are all types of other data that we're going to collect for you automatically. And then from an integration standpoint, how do you use Device Farm? So in today's demonstration, Nikhil will go through how to use our console. This is the user interface for Device Farm. We also have official plugins for Jenkins, if you're using continuous integration. We also have a plugin for Gradle and Android Studio, so you can use it right from your IDE. And then we also have our API available in the AWS SDKs, which are available in a number of languages out there, and the AWS CLI. So no matter which tools you're using or what you want to do, you can integrate Device Farm into your workflow. Everything that you see today in Nikhil's demonstration that is on the Device Farm console can be done through our API. You can pull a screenshot from a specific test on a specific device. You can pull the aggregate report. It's a very granular API, so you can pretty much do whatever you want with that. Real quick, a note on pricing. So first of all, you can get started for $250 per month unlimited testing. These are device slots. A device slot is, you can think of it as a piece of concurrency or an item of concurrency. So if you bought 5 Android device slots, you could select 10 Android devices. It would just run 5 at a time until it was completed. You can schedule as many tests as you want in parallel. It's just concurrency will be limited by the number of slots you have. And those slots start at $250 per month per slot. And you can learn more. There will be a link at the end of the presentation that talks more about that. Another option you have is to pay as you go. So you can pay 17 cents per device minute. So if your test takes 5 minutes, you run it on 5 devices, you will be billed for 25 device minutes at 17 cents each. We also offer private devices. So this is dedicated hardware. You select the make, model, and operating system. We deploy a physical instance that's only available for your account. It's brand new when it's deployed. When your contract is up, we destroy it. And it provides you with 24/7 availability, so you can access that device. You know it's going to be available when you want it. It also provides a level of security. Since you're the only you're the only account that will ever have access to that device, you can rest assured that there's nobody else's apps ever touching that device whatsoever. And everything that you see today, you can go and check it out afterwards, and we would encourage you to do so. You can start today with 250 minutes for free. That's a one-time free trial, and after that you can make use of 17 cents per minute or buy a slot or even mix and match those two. That's fine too. Or if you're interested in private devices, you can contact us. A quick note on availability. We launched in July of 2015, so we're coming up on the 2-year mark. We are available in the US West region. However, it's available globally. You'll notice when you access Device Farm, you do not actually have to select a region. It will just work. And we have customers all over the world testing their mobile applications. So even though the devices are here physically in the US West region, they're available for testing globally. And I think Nikhil will also touch on some of the features and functionality that we have to even simulate other environments. So even though the devices are here, you can simulate that those devices are elsewhere in the world, and so on. And of course, you can access Device Farm through the AWS console. A quick note on use cases. So we see developers using Device Farm to test iterative changes during development. We also see them testing cumulative builds, so this gets into this continuous integration story that I was mentioning before, so things like Jenkins or Gradle. We also see developers verifying functionality, so as they're developing, they're making sure that that functionality works on their target devices. We also see developers set up automated canaries that run periodic tests using our API. Make sure that the device is able to communicate, or their app is able to communicate to their backend systems in a real-world environment, and catch issues potentially before they affect customers. And finally, reproducing issues reported by analytics. So if you have crash reporting built into your app, or you use a service like that, you may talk to a customer or just take that crash report and then reproduce it on Device Farm, either using automation or maybe using the remote access feature I mentioned before and manually reproducing issues. And with that, I will hand it over to Nikhil to talk about Espresso.
Thank you, Trent. Hello, everyone. My name is Nikhil, and I'll be going through the Espresso test framework. After that, we'll touch on how do you use Espresso Recorder to test your Android, to write tests on Android. And then finally, once we package these tests and upload it to Device Farm, we'll see how can we leverage the power of Device Farm to look at your test results. Moving forward, what is Espresso Test Framework? In very simple terms, it's a set of APIs in the Android testing support library for writing UI tests or simulating user interactions within a single target app. Note the two important things here is the UI tests and the word single target app. UI tests because Espresso tests are designed to be functional UI tests, and these functional tests are only targeted towards a single app. Users may have a requirement where they want to have different apps interact with each other. For those cases, you would use a framework like a UI Automator, both of which are supported by Device Farm. You can also have other unit tests that are not purely UI tests embedded inside Espresso Test Framework, but the primary motive of having Espresso Test Framework is to have functional UI tests. Espresso Test Framework runs on devices running Android 2.3.3 and or above, and these corresponds to API level 10. And then Espresso Test Framework supports automatic synchronization of test actions with the UI of the application under test. What this means is, suppose you have a sample application or your actual application that you want to test, and say it has a user login page. which has a username, password, and a login button. Now, if you were to write a test from scratch, you would have to actually open up the page, go to the page that shows up the username and password and the login button, check for the existence of this username and password text field, and then once you enter those fields that you want, you press the login button and wait for the next action. Now, you notice that we are trying to do a mix of user interactions with test assertions in this, where we go to the page, we check for the existence, then we add an assertion saying, hey, does this text box exist? You do not, when you're using Espresso test framework, you do not have to worry about how do you synchronize these test actions and mix of assertions. Espresso test framework does it for you. And Espresso test framework works with Android JUnit runner. Android provides us with different types of runners, and Espresso test framework works with Android JUnit runner. The other runner can also be the old instrumentation runner. You can also run Espresso test against those. Moving on, now that we have touched upon what is Espresso test framework on a high level, we want to dig deep dive into how do you use the Espresso recorder to record your tests using Android Studio and then run these tests on Device Farm. The high-level steps that we're going to go through are, we're going to first record tests using Espresso recorder. Now, what is a Espresso recorder? In simple terms, it's a tool that's bundled with the Android Studio that lets you record your user interactions and add assertions, thereby generating the test for you. You do not have to write a single line of code when you're using Espresso test recorder, and all of these tests are supported out of the box, and you can run these on Device Farm. You can also have a sanity check on a real device that is attached to your machine or an emulator. So nothing is stopping you to run an Espresso test on an emulator or a real device. Once we have the test recorded with using Espresso recorder, we're going to run these recorded tests locally. I'll also walk you through on how do you quickly configure and run these tests locally and on Device Farm. Now that we have run the tests successfully locally, we'll generate the APKs for the app and tests. Espresso requires that you have your test application, and it also helps you generate an APK file that corresponds to your Espresso tests. The next test is when we have the generated APK and test app, we upload these to Device Farm, and then we trigger our run. Once we have the results from the run, we analyze the results on Device Farm. I'll show you the actual power of Device Farm when we actually look at the test results. I would like to now switch on to sharing my screen over here to show you Android Studio. All right. So as you can see, I already have a project open inside my Android Studio. This project is a AWS Device Farm sample app for Android. Where did I get this app from? If you go to github.com and look up AWS Device Farm, you'll find a bunch of sample applications or sample applications hosted on GitHub under the handle AWS Labs. We are going to just focus on the Android sample app. Moving back to Android Studio, if I have to show you how the application looks in general, you can see my emulator on the screen. This is our sample Android application. Let's go ahead and look at the menu real quick. You'll find it has several UI components in here that are used by most applications today. You have an embedded web view, which also makes this app a good candidate to test your hybrid apps, or treat this app as a hybrid app to write your tests. It also has native components like camera, video recorder, music player. It also has input components such as text field, checkboxes, radio buttons. And then others that are listed over here are nested view. There's also an option to crash your application, just so that you want to see how an application crashes and looks on Device Farm and how do you handle those cases. Then there's also alerts, which shows you different types of alerts. And then there's a login page. So the whole point of this sample application is to have as many UI interactions as possible so that you can play with those and write your tests using different test frameworks. For now, we'll focus on just Espresso tests. So how do you get started with the Espresso test recorder? When you have the Android Studio open, you'll find there's a menu option right on the top under Run, and that says Record Espresso Tests. once you run this, it's going to ask you the target on which you want this test to be, or you want the test recording session to run. Since I have the emulator already open, I'm going to select that. It will take, so it runs a Grail process in the background, and it does take a while once in a while. So while it's running, I want to bring to your attention the sample app and the other test frameworks that are available on GitHub. If you go on this main page, you'll find that there are other tests over here apart from just Espresso. We also have Calabash and Appium tests hosted on GitHub, and if you click on each one of those, it will directly take you to the source application. All of the instructions that I'm going through today will also be available on this GitHub page, right in the below, where it talks about how do you write Espresso tests and how do you set those up. Moving back to the Android Studio, you see that it popped up a window that says record your test. This is the main Espresso recorder window. Now, I'll have the emulator on the side. So the idea here is while I'm browsing the app, the recorder will record my UI interactions as events, and then while I'm doing that, I can add assertions or checks which ultimately translate to auto-generated tests in Espresso. So let's say I clicked on the main menu button. You can see that the first event that popped up here is tap image button with content description reference app. What that means is my main menu button was an image button, and that had a unique identifier, the content description, which was called as reference app. Now let's say we want to write tests for the alert box. So I'll click on alerts. You can see that it recorded the unique way in which it identifies the alert option in the menu in the UI hierarchy. It recorded that event over here. Now let's say there are two types of alerts over here, toast and alert. Now let's say first I want to check for the existence of alert. So what I do here is I say add assertion in the Espresso test recorder window. What it's going to do, it's going to capture the UI hierarchy of the device and take a dump of the elements present on the screen. As you can see, as I hover around on the screen in the UI dump hierarchy that was captured, there's a red background that gets captured or displayed on the UI elements. Now if I say alert and move back to the Espresso window, you'll find that it uniquely populates the field, the first field, which is the unique identifier in the UI hierarchy for the alert box. There are two types of option, exist, does not exist. So we want to do exists. I choose that and say save assertion. So you see the event that was captured here was assert button with ID and the unique ID of that button. Moving back to the emulator, let's say we want to test how does the alert button behave. So when I click on alert, it recorded an event called as tapping button with alert. Now I say I want to check whether the alert message box did pop up and it displayed this message. So I will add an assertion over here. It again goes through the same exercise of dumping the UI hierarchy and going through and giving me the exact screenshot. And if I hover around on the text message, you'll find that it again uniquely populated the Android ID of this text field. We get three types of checks over here saying text is, exists, and does not exist. We already used the text exists option. Let's try and use the text is option. The text that we want to see is automatically auto-populated. You may have a negative test case and write some other test and have the test fail. In this case, we just want to do a positive test, so we'll do save assertion. And in the end, moving back to the emulator, I want to dismiss this pop-up message. So I'll click on OK, and then you can see that it recorded it. Now that we have a scenario recorded over here, I'll say complete recording. As soon as I say complete recording, it asks me for a name that I want to give to the test class. This test class will have the entire user interaction and assertions that we just walked through. Let's call this as alert test. And I'll save this. You can see that the auto-populated code shows up on Android Studio. If you look at the code on a really high level, you can see that it has a test, alert test, with an annotation test. We first click on the reference app button. It says perform click. If we scroll down further, you'll see that it it tried to navigate to the navigation drawer where we selected the alert option. Then it checked for the existence of the notifications alert button. So our first assertion shows up here, button.check. Then if I move further down, you can see that it also clicks on the alert box, which performs a click. And then lastly, it checks for the existence of the text message that we want to check against, which is this is the alert message. So our second assertion shows up over here. Now, how do you run these tests locally? So it's a very easy way, and Android Studio makes it really easy for you to configure that. So I'll need to create a configuration to run the Android Espresso test. So I'll say edit configuration. I'll need to add a new configuration for Android tests. Now let's call this as Espresso test. The module that we want to have these tests running against is our app. So I'll select that module. Since we have just one test and all of those tests are in the package activities, in our case, the place where Espresso Recorder populated the test application or the test recorded test, we'll only select that package. So I'll select all in one package, and I'll navigate to the package under which my auto-recorded tests are present. Going back to, so the test where the alert test is stored is activities. Now here you'll find an option where it tells you or asks you which runner do you want to use to execute your test. So you have three options. As mentioned earlier, I want to use the Android JUnit runner. And that's it. I'll save this configuration. And now if I have to run the tests, I'll just say run. It will again ask me for the target device on which I want to run these tests. I'll kick this one off. This should take a while for the test because we created a new configuration. It does take a minute or so for it to kick the test and actually deploy and show us how it runs. While it's doing that, I want to bring to your attention again our GitHub page where we already captured all of these steps on how do you have the local configuration for Espresso tests. Now that we have these tests, and I'll wait for the test to get over and jump back on them when it's ready to run as we expect them to. We want to bundle these tests and application to upload this to Device Farm. So how do we do that? So I'll go to a terminal. In the terminal, I have this folder under Webinar. I did a git clone of the Android sample app that I have. If I go inside that folder, we use a command called a Gradle wrapper. So Gradle W is the command that we use, and we pass it CC, which means that it will not only bundle your application, but also run it from command line. So if I execute this command, this should kick off the entire build process where it gathers all the dependencies mentioned in the Gradle file, and it will go and fetch everything that's needed to build your APK. So this does take also a while. So what I'm going to do is, in the benefit of time, I'm going to skip this step and just show you where the exact output is stored. So if I go under App, Build, Outputs, and APK, so here you can see that it has my app already built. So let's go ahead and kick off the actual build because I don't have the test APK over here. While that's running, let's see if our Gradle build already kicked in. So it seems to be doing something over here. Let's go and check out on the emulator. It's still running. So while it's running, we'll have both of them running, and now I want to switch our attention to Device Farm. So I think it already invoked. Let's see how it runs locally. And then we can switch to Device Farm. You can see in the activity log below that it's instantiating the tests. It pushed the app. Now it's installing the tests. And what it will do is it will show us the exact user interactions as we did it. So you can see it went to the alert bar pops up, and that's it. So it seems that the test passed over here. Oh, it says process crashed. So the process crashed, but the test passed. So since Espresso Test Recorder is in beta, I would recommend if it shows this kind of a behavior, you should rerun it, because the Espresso Test Recorder is still in beta as per the Android documentation. But the instances on which it actually crashes after finishing the test is pretty low. However, the test still did pass. So let's kick it off once more while we go on Device Farm and try and upload these tests. Going back to the Device Farm, this is the main AWS console management page. And if you see here, you'll find that Device Farm is located under Mobile Services in Device Farm. The other easier way is if you just search here for Device Farm, it will show up. And if you've already used it at least once, it will show up in the recently visited services. So let's go ahead and load that up. So here we are at the main AWS Device Farm console page. You'll see that the layout is a card layout where we can see all of the projects arranged one after another. What we want to do is you can have a project that will contain all of your test runs. So a project is the highest level container object that has all of your runs. Now we can create a new project over here. Let's say test webinar. And then it creates a new project. For this purpose, let's go back to our main one and just use this webinar project that I already have. This is for the ease of use so that I can show you comparative runs from previous runs and show you how different runs and different execution results look like. So if I just create a new run again over here, we come to the schedule run page. Now, if you want to schedule a run on Device Farm, you'll find that it's divided mainly into 5 steps. First, we provide an application. Second, once we provide an application, we have to give it the tests package. Now we want to tell it where to run these tests and your application on which set of devices. So third step is our select devices. Then fourth step, we specify a device state, and I'll go into more detail when we get to that step. And first, we confirm all the details and we trigger the run. So first step, we choose the application. So Device Farm takes your native iOS and Android applications along with web applications. You can also supply hybrid applications to Device Farm. Since in our case, the one that we're trying to test is a Android native application or a hybrid application because it also has a web view, you can go ahead and select that. You can see that it generated my Gradle W command executed, and now I'm in the APK folder. So I can select this app over here, and instead of uploading it over here, which is really quick, we also have a recently uploaded one. You can see the one that I just uploaded a day ago, and I can select that from my recent upload. What it does is once you select and upload the application, it will parse your application first and grab some higher level metadata from your APK file. It tells you what's the package name in the APK, what is the main activity that is listed for this APK. It also tells you the minimum SDK and the target SDK configured for this application. And if you have any versioning, it also grabs that. You can give a custom run name to this run, but if you don't give one, it will just take the name of your application as the default run name. Now, we have the application. Now we want to give it the test. Here you can see that there's a list of test frameworks that it provides. The first two are built-in Explorer test and built-in Fuzz test. Now what do these mean? The built-in Explorer test is mainly focused on having random UI events across your devices. So the main difference between the Explorer and the Fuzz test are the Explorer would have random UI events across the device. So say if you have an application open, it could do events like scroll down the notification bar, switch between apps, press the back button, press the app switch button. Those random events are not fixed. They are, as the word says, completely random. In case of Fuzz, the whole random event are based only on a single target app. So when your app comes up, it works as a monkey runner, which will completely target and focus on your app. You can give it how many events you want, and you can give it a throttle, which means what's the time difference that you want between two consecutive events. You can see we support two of the most popular open source test frameworks, Appium and Calabash, And we also support multiple flavors, language flavors for Appium. Instrumentation can be your JUnit 4 test, they can be your Espresso test, or they can be the old instrumentation style test that Android had before they came up with Espresso test framework. And lastly, you also have UI Automator, which is if you have a cross-app test functionality, you can use UI Automator, which is better suited for apps and tests that span across multiple applications. Since we are doing Espresso test, we'll select instrumentation. And if I have to upload it over here, I'll select the second APK, which has the suffix Android test. Once we run the railw command, I'm just going to select the preloaded app. And it also passes this test APK, and you can see that it picked up the test package and the runner that's going to be used for this test. There's a test filter tab over here, and this gives you really the ability to control sets of tests. Say if you had 20 tests that you recorded and you just want to run the first 2 tests or only the tests related to the alert class, you can go in here and just specify the name of the test class, or you can have multiple test class which are comma separated, or you can also have just a package name and it will execute all the tests under those package. Since we have just one test, I'm just going to go ahead. Now here's the real beauty of Device Farm. You can see that on the first page of the select devices, you can see these auto-populated devices, and this is our top device pool. What this means is this is a curated list that we come up with and update regularly based on customer demand and customer usage. And we also look at how the market is doing, what devices are being used. So considering all of those and other factors, this list is always updated. Now, one may obviously not want to test on this. The whole point of Device Farm is to have access to multiple devices on different OS versions and makes and models. So how do you do that? Let's say we'll create a new device pool over here. So all the set of devices on which you want to run your tests will go under a device pool. You can have more than one device pool. You can even manage them. You can add and remove devices from them. Let's say we create a device pool on which we only add Android 6 and above devices. Now, you'll see a few things over here. I'll want to scroll down first and show you that once you get down to this select devices list, you'll see the entire fleet being offered by Device Farm. You can see that you can have the same make and model with different OS versions. Say, for example, you have a Samsung Galaxy Tab 3, which has even the minor version changed. So that's the fleet. One point to note is when you see one device, this doesn't mean that this is the only device. We have multiple instances of the same device. This list only, or this name or this entry, only shows you the device type that we have, and we have multiple instances of each one of those devices. It also gives you a neat way to filter based on 6. So say, let's say we were looking for only Android 6 and above, so I say 6 over in the OS section, and it will only show me Android 6 devices. You can also see that if I switch it to iOS and remove the 6, it will show me all of the iOS devices. Since in this test we are only doing Android, I'm only going to stick to Android. Going back, I'll say 6, and I'll select Android. Once I do that, let's say our emulator was a Nexus 5. So we ran it on an emulator, and now we want to test it on a real device. So I'll add a LG Nexus 5 running 6. Now let's pick one of the other popular devices like a Samsung Galaxy S7. So we have a Samsung Galaxy S7 with AT&T, and we have with the 6.0.1 version. Let's select that. You can also notice that not only do we have a Samsung Galaxy S7 offered by AT&T, but also by T-Mobile. So the device offerings also vary by carrier. And now that I have these two devices, I want to quickly reflect on this add rules. Add rules can help you manage or select devices real quick. So say you created a new device, and every time you come in, you want to only have, say, iOS devices that are greater than 10.1 or 10.0. You can write a rule over here that will quickly give you access to all of those devices rather than you going to manually go in and select those devices every time. So let's say we save this device pool. So to quickly configure a run, our recent upload helps here because we already had uploaded the tests and the application. So I'll quickly go over there. Next. Select my Android 6 pool. Say next. Now here's the page where it shows you the extra data install apps. So I'll go through each one of these real quick. Extra data is, say your application or test has media files, configuration file, properties file that may not be bundled with your test. You can provide this in the form of a zip file. And in case of Android, this zip file gets extracted to the SD card. And in case of iOS, this will be your application data space. You can also have other apps in addition to your application under test. Say you need Facebook, Instagram, or Twitter, or any other social, or any third-party app that you want to use or have present on the device while you're running your test. You can supply over here. Then you can configure the radio states like Wi-Fi, Bluetooth, GPS of the device. And Trent mentioned about the device location, and this is a powerful feature where you can give the latitude and longitude to the device, and it will set the location of the device to that place. An example use case would be a bank application that wants to show ATM near a certain location could use this feature. Then you have the device locale where you can set the language of the device. And then we have this network profile. This is a powerful network shaping tool, and what this does is it gives you pre-populated configurations of network like 3G all the way from lossy to good connection. And if I keep on scrolling down the list, you can see these are pre-populated lists that help you configure your network under which you are going to run your tests. You can also create your own network profile over here by having each one of the values as you find it suitable. Now, we are back at the review page. We are at the review page. Here you can see a new feature that we recently added, which lets you configure the maximum timeout of your tests. Right now, Device Farm runs a test for 60 minutes, and this could, maybe you could have tests that run or require execution time to be more than 60 minutes. In that case, you can contact us and we can configure it for you. However, there may be cases where you don't want the test to run there more than, say, 10 minutes. So you can easily move the bar and just have this maximum timeout configured. Let's just say confirm and start run over here. So it's going to go out, fetch instances of these devices and schedule your run. For saving our time over here, I have the exact same run on the exact same devices running our exact same Espresso test. So once the tests are finished, you can see that it shows me how many number of tests passed. If I go in just one of these, you can see that it has a setup suite where we actually make sure that the device is cleaned up. There are no pop-ups on the device. We have all the extra apps, extra data, and everything set up for the device. And next comes the test, where you actually have the test execution and then the teardown suite. If I have to go on the test, you'll find that Device Farm provides you a neat video of the entire execution of run. And if we just scroll through these, you can see that it opened the app, went to the alert box, and then pressed OK, and then came out. So that was the whole video. The other part is it really neatly organizes all of the logs that came as a part of this execution. So you have harness logs, you have device and test logs. Harness logs are nothing but the logs that are present on the device host or your host execution machine. Your device is your logcats and syslogs in case of iOS, and your test logs are relevant logs like Appium client log, Appium server log in case you're running Appium. In this case, we are just running Espresso, so the device host machine log should suffice. You can also filter or look for messages really over here in the source folder, and that makes your job really easy. Then we also capture the performance data where we show the CPU, memory, and thread usage over time. Going back, you can also have the files in a downloadable form. And then you have the screenshot section. The screenshot section lets you capture the screenshots of your tests, and these can differ depending on the test framework that we use. Our documentation captures this in complete, you have the APIs listed in the documentation that you use to capture screenshot on different test frameworks. And I want to show you how other type of tests look. So this was the case where we find that test passed. What if the test failed? In this case, let's look at an execution over here. Here there are several runs. You can find that some runs have device pass, some runs have failures in them. And then there are these other ones that you might think, what are those? So the blue one indicates the tests were skipped. This might be because this hit an execution time limit. The device stopped might be we provide the ability for a run to be stopped. So the orange one with bars show you that the 5 tests were stopped in this run. And in a rare case, you will find this this red bang error that we see on the run, and that means that something maybe either went wrong with the device, or there was an error on our side, and we'll bubble up that error explicitly to tell you what exactly happened. So if we look at a failure over here, here is where Device Farm makes your life really easy. So this test had 1 failure. So now you can see the section where it says unique problems, and it shows us what was the problem. It didn't find a matching view in the hierarchy. And if I expand on it, it tells you that this error happened on 4 devices, but on 1 device it passed. So it really filters out the unique problems across all of the set of devices and then shows up to you so that you don't have to bother and go in and dig on the logs of each one of those and say, is this the same error that you saw on some other device? And going back to the main view, I think our tests are still running, and they're almost complete over here. So they will have the same execution thing. If I go back here real quick and run this, you can see it did the same thing. Now we're done with this, the console and the Device Farm analysis of the test. I would like to switch back to the presentation. So we did all of those. Next is we offer plugins for configuring Device Farm via Jenkins and Gradle. This makes life easier if you have a regular continuous integration where you just change a line in your app and in your test, and all of these are executed on Device Farm once you configure the Jenkins or the Gradle plugin. We also have a command line interface. This makes automating your processes and your scripts easier. And then since Device Farm is a part of the AWS SDK, it comes in different flavors like Python, Java, .NET, amongst others. With that, we have concluded what is Espresso Test Framework, how to use Espresso Recorder to record your tests and run them on Device Farm. I would like to now hand it over to Jerry and open the field for Q&A.
Thank you, Nikhil and Trent. Thanks for the great presentation and all the great content today. On your screen, you will see our poll questions on the screen. See 3 at the bottom, 1 at the top. Please feel free to fill those out. Feedback's very important to us. See our Q&A slide right in the middle of the screen there that has some links there for you. And we also have the Q&A panel still open in the upper left corner of the screen. Feel free to keep entering your questions there. About 11 minutes here to run through our Q&A. So again, this time I'll go ahead and hand it over to Trent and Nikhil for the Q&A session.
All right. So first question we have, do you plan to support all Appium versions in future, that is 1.6.3, 1.6.4? Yes, we try to keep up with the latest version of test frameworks. Right now we do have support for Appium 1.6.3 for iOS 10 devices. We are planning on having other devices included as we go along. Since having the latest test frameworks we know the importance of having them in place so that developers can use the latest and greatest. The forum would be the best place to check for this, or you can contact us on the AWS Device Farm support alias, where you can get an up-to-date status on which versions are currently in works and what are we planning on supporting. So the next question is, what network connectivity do these devices have? Cellular, Wi-Fi, tethered via USB. So all of these devices have Wi-Fi connection on them. The cellular part can be because we saw a device during our run like AT&T and T-Mobile. What that means is this is an actual device that you would go ahead and buy from AT&T. The devices do not have a SIM card, but it gives you the capability to simulate the network conditions as we saw with the help of a network profile. So all the devices are on Wi-Fi. They do not have a cellular connection. The next question is there any cost associated with pulling the video reports and other test artifacts? No, there is no cost. The only cost incurred is actually the test minutes that you used and the other cost models that Trent touched upon if you buy a device slot where you can have unlimited usage for $250 a month. So you're only being charged for the device minutes, not for how many artifacts do you pull or how many tests do you run. You're only being charged for the device minutes. The next question is, are the devices able to use any carrier or have specific dedicated carrier cards? So this is a continuation of the previous question that these devices run on Wi-Fi. They do not have cellular SIM card in them. Other question, can Espresso be used as a standalone app outside of Android Studio? This is an interesting question. So Espresso gives you the ability to export your apps in the form of an APK. However, if you go back to the emulator and see and just follow the instructions on GitHub, there is no APK that you can click on and have it run individually. So the Espresso APK does work with a target test application. So when you say can it work outside of Android Studio, sure, you can install it on the device and trigger it with command line. But the whole integration with Android Studio lets you provide the test runner and other artifacts that are needed to trigger it. Can you use it outside Android Studio? Yes, you can if you figure out the command line way of running it. Second is, how do we access the plugin for the test recorder just shown? So if you download the latest version of Android Studio, the Espresso test recorder comes bundled with the Android Studio package. You do not have to explicitly go in and download or install any of the plugins or any dependencies whatsoever. The next question is, when paying $250 per month unlimited tests per device unit, does one need to enter a multi-month contract or can they subscribe month-to-month as needed? So the $250 per month is actually per month. You do not need a multi-month contract in any way. You can cancel and upgrade anytime you want, and the charges will be placed accordingly. So no, you do not need a multi-month contract for using the device slots. Next question is, can we run multiple types of tests simultaneously, that is Espresso and UI Automator in the run, or do we have to configure multiple tests? You can have multiple runs that each run different types of tests. So when I showed that I scheduled a run that ran only Espresso test, you could have Espresso test and a UI Automator test in a completely different run. However, if you're saying that can we mix Espresso test core and UI Automator, if you can do that locally in your Android Studio by importing all the libraries, then I don't see any way why we shouldn't be able to support it. In that case, you want to make sure that if you're running it with Android JUnit runner, your UI Automator test can run with that runner, because the test runner class that we use for UI Automator is instrumentation. So mixing those two might be a challenge. However, I have not seen a case or executed this in person. However, I don't see a restriction if you can make it work locally. Is it possible to integrate Device Farm with AWS Code Pipeline so that I can auto-build, test, and deploy? For AWS Code Pipeline, I don't think the support for AWS Code Pipeline is there right now. But you can use our CLI or SDK to have a step inside the AWS Code Pipeline. I'll let Trent elaborate a little bit more on this.
Yeah, and there is actually a blog post out there that shows how to use Code Pipeline, Code Commit in AWS Device Farm to kick off tests on Device Farm directly from those other AWS services. I posted the link earlier in the Q&A section as an answer. Somebody asked a similar question. But you can find that on our blog, which we don't have a link in the Q&A. But we can send out a link to the blog post so you can find out that, follow along with that tutorial.
Okay, thank you, Trent. So the next question is, what is the turnaround time for switching devices? Does this time count towards purchased minutes? Trent, you want to take that one?
Sure. So there is no, for turning around and switching between devices, when you configure a test run on Device Farm, you select the devices you want. As we find a physical instance that matches the device you specified or the devices, we'll start running tests. We don't charge you for the time it takes for us to find a physical instance and to assign it to you and so on. We start billing around the time when your application is installed until it is uninstalled and your tests are completed. So there's no charge for the time it takes for us to find those devices. Similarly, if you're using remote access and you're manually interacting with the device, if you stop your session, it's stopped. You start another session. There's no real billing concerns between those. And if you have additional questions about billing specifically, feel free to email us at our support email, which is visible on the screen right now in the Contact Us page, and we'll be happy to answer any questions you might have.
Good, Trent. The next question is, how do you have devices interact with each other? So all of the devices have their own Wi-Fi network to which they connect. They are not connected to the same Wi-Fi network, so no sort of peer-to-peer communication or proximity communication is possible. However, if you have apps that are deployed on multiple devices and can talk to each other via cloud, that functionality should be accessible to you. We do not restrict your internet access in any way. The devices are free to access and browse whichever way or communicate out to the outside world in any way they want. However, when you talk about devices interacting with each other like I am, and if you're expecting them to be on the same Wi-Fi network, they are not. The next question is, when we use Device Farm, we see that few devices are marked as skipped. When is a device skipped and stopped? So as I captured this during the demo that I was doing, for a device to be skipped, there may be multiple reasons. The most common reason is you had tests that took more than 60 minutes to execute, and so it hit a execution timeout of 60 minutes, so all the remaining tests in the end get skipped. The test could also get skipped because we were unable to parse a test. This usually could be a packaging problem or test parsing problem where, say you were using some Appium test annotation which may not be supported by default, and those tests were unable to be parsed on Device Farm. So those tests, the device gets skipped because it could not schedule a run. Other way could be that you selected a device for which a target SDK version was different from the devices in the device pool that you skipped. In this case, it will not schedule a run and just skip device. And in case of stopped, you would have to explicitly go in the run and stop the run for the test to be marked as stopped. The next question is, are these real physical devices or emulator simulator? If there are both, is there a way to distinguish between them? All the devices offered on Device Farm are real devices and not emulators. So anything that, all the device listings that you see are pure physical device instances. And I think we are short on the time, so I'll hand it back to Jerry. So I think we are concluded with the Q&A. Jerry, I want to hand it over to you.
I'd like to thank our presenters for their great presentation and all the content today. And I'd like to spend a special thank you for their time to put all this together for us. If you have any comments on our previous or upcoming webinars or suggestions on the topics you wish AWS to cover in the future webinars, please feel free to email to aws-webcast@amazon.com. Your feedback will help us improve our webinar programming. Thank you for the audience today for joining us today. At this point, you can disconnect from the session. Have a great rest of your day.